Mr. Heffern here, and here's a short tutorial on how to do ray diagrams for circular mirrors, so they'd be concave or convex, and how to use the equations to determine the properties of the image as well. So here we have a 3 centimeter tall image of Min May, the singer from Macross City, and Min May is 10 centimeters away from a concave converging mirror. And this mirror has a radius of 8 centimeters. Okay. So what you should know, if it's a circular mirror, then the focal length will be exactly 1/2 the radius. So that's going to be a 4 centimeter focal length. And to find the location of the image, you only need 2 rays. I'll do all 3, but you only need 2. So the first ray, starting off at the head, is going to go straight towards the mirror. If the ray is parallel to the principal axis, this dotted line right here, then the ray will reflect back through the focal point. So it's going to come back through this focal point right here. Okay, so just going to draw that ray. There we go. Okay, so if you start off with an incident parallel to the principal axis, you reflect back through the focal point. Now I'm going to get a second ray. The second ray is going to be from the head as well, and it's going to pass through the center point. Now I didn't draw the mirror big enough, but if I hit the mirror all the way down here, it would reflect directly back in the direction it came. Alright, so now I can see that I can find out where my image is going to be. My image is actually going to be like right here where these 2 lines converge or intersect, and this would be the location of my image. And I can see from looking at it, my image would be inverted or upside down. So I'm just going to put my image there. So let's just grab this one here. And let's see, there we go. Drag that down there. Now, as you can see, my image is a little bit too big, so I'm just going to shrink it down to the correct size. And there we go. That's where the image would pop up. Now, the other ray you can draw, if you want, the third optional ray, is it's going to start off at the head. It's going to go through the focal point right here. And then it's going to bounce back parallel to the principal axis. So it does the complete opposite of the first one. There we go. Now, as you can see, my diagram is not perfect, so this ray didn't exactly intersect. It should have intersected right here. So probably my focal point's a little bit off. I'll just move it over a bit. There we go. There we go. So it's just not perfectly to scale, unfortunately, but it's the best you can do sometimes. And that actually demonstrates why the math is even better. So we're going to take a look. But as for now, you can see it is inverted, so I'll just bold inverted. I could stick a screen there, and it would pop up on the screen, so it's real. And I can see that it's definitely going to be smaller. Okay, so now we're going to use these numbers, and we're going to plug them into the equations here to solve for what the image would look like. So first of all, you want to find the focal length. So as you can remember, the focal length is just going to be half of the radius. So if we have an 8 centimeter radius, okay, then our focal length will be 4 centimeters. Okay, there we go. Okay, now what we'd like to do is find the location of the image. So hopefully it'll be somewhere between 0 and 10 centimeters. So we'll find out. Okay, so we're going to use the focal length formula. Okay, just tab that over. There we go. Okay, so the focal length was 4 centimeters. So I'll put 4 centimeters here. The object distance, if we go back to the picture, was 10 centimeters. So I'm going to put 10 centimeters right here. There we go. And so now I'm just going to isolate for the image distance right here. So all I got to do is bring the this positive 10 centimeters over to the other side and subtract. Okay, and then of course you need a common denominator. So 4 and 10 both go into 20 conveniently. So I'm just going to make that 2/20ths, and I'm going to make this 5/20ths. There we go. Okay. And so 5 subtract 2 is 3. We're going to get 3/20ths. And then all we got to do is just invert and cross multiply. So we're going to get a DI of exactly 20 centimeters divided by 3, or 20/3. And 20/3 is 6.67 centimeters. Okay, so if you're not sure about the math, maybe just take a quick look at that on your own. Just go through it, and you'll see that makes sense. So the image should be 6.67 centimeters from the mirror. So let's go take a look back up here and just check. So if I just make a little line right here, okay, from the vertex to my image, and I can check 6.58. It's pretty close, right? The diagram will never be perfect, but it is close to confirming my mathematical equations. Now the only thing left to do is find out the image height and the magnification. So I'm going to use the magnification formula for that. Okay, so just pop that over here. Okay. Okay, so we are looking for the high and the magnification. So we know the HO first of all. So the object was 2 centimeters tall. So 2 centimeters. Oh, actually no, sorry, that was 3 centimeters. Let's just fix that. 3 centimeters. There we go. 3 centimeters. And the image distance we just found to be 6.67. So that's going to be 6.67 centimeters. Okay, there's a minus sign in the equation. You have to keep it there. And the object distance was 10 centimeters. There we go. Okay. So using just these two portions of the equation here, I'm going to cross multiply that 3 centimeters over to the other side. There we go. Just plop that in there. And so we can find the height. So it's going to be 6.67 times 3 divided by 10. So you just do that on a calculator. So 6.6666, really it was rounded off, times 3 divided by 10. It's going to be exactly -2. So the height should be -2 centimeters. So -2 centimeters. There we go. I'd also like to find the magnification. So to find the magnification, I'm just going to use the first and last part of the equation there. Okay, let me just space this out a little bit. There we go. And so it's just going to be 6.67 divided by 10. And so that's going to be negative 0.67 times. Okay, or you could say it's going to be 67% of what it used to be. There we go. Alright, so if you just take a look back at the picture, that's about right. If that's 3 centimeters, if that's a 3 centimeter object right here, and we go take a look at our image, and we just adjust this a little bit, there we go. We'll see that at 2.43, it's a little bit off, but that's the picture, right? Again, the pictures are never perfect. And there you go. So you got all the information for a quick converging lens. So we'll try converging mirror. So we'll do another converging mirror. The next one will be a little more difficult. It'll be with the object being closer than a focal length. So we'll try that in the next video. Good luck.